Today we're going to look at factoring by your GCF. Okay, so if I were to think back to when we learned distributed property, and if I were to say for you to use the distributed property to multiply these, you would take this 3 times it by your x, take your 3 times it by your negative 5. You would end up with 3x minus 15. Now if I were to ask you to do it over here, you would do the same thing. 2 times 4y 2 times 5. So that would be 8y plus 10. We would do the same thing with this 3a. We would say 3a times 2a is actually 6a squared. 3a times 10 is a positive 30a. Same thing for this one. I'm going to take my 4x squared and distribute it. So 4x squared times 3x is going to be 12x to the third. Now remember, with these two and these, we are using our laws of exponents to help us, where we have to add our exponents when we are multiplying. So keep that in mind for these two. 4x squared times negative 10 is a negative 40x squared. So now, what if I were to make you think backwards? Here is your distributed property, 4x minus 20y. If I'm left with just x minus 5 inside, what did I take out? What did I divide out from both 4x and negative 20? Well, to go from a 4x to an x, I divided by 4. To go from negative 20 to negative 5, I divided by 4. So 4 is what I distributed out. Let's do the same thing over here. I'm ending up with 24y plus 30. So what's being distributed out? So 24y, and you can always rewrite it, 24y divided by 4y. Okay, well, your y's would cancel. What's 24 divided by 4? Well, that's 6. Let's see if the same thing works. If I do 30 divided by 6, do I get 5? Yes. So 6 is what I distributed out. Same thing on this one, except for now, stepping it up a notch. I have 10a squared, and I'm left with a 2a. So if I divide that out, that's a squared. This is a to the first. So 10 divided by 2 is 5. A squared divided by a to the first is just an a. So it looks like I'm dividing by 5a. So let's check this with 50a. 50 divided by 5 is 10. My a's cancel out, and I'm left with that. So it is a 5a that I'm pulling out. And again, I can sit here and kind of rethink my distributive property. If I multiply these back, do I get 10a? Yes. If I multiply 5a and 10, do I get 50a? Yes. So now let's do the same thing over here. Again, you're starting with a 3x, and we have our negative x to the third divided by 3x to the first. So 9 divided by 3 is 3. X cubed divided by x to the first is x squared. Let's see if it works over here if I divide by 10. 3 divided by 10 is, or 30 divided by 10 is 3. X squared divided by nothing is still x squared. So I'm factoring out a 3x squared. So I've literally factored out something that they both have in common. Well, factoring is where you have two or more numbers that are multiplied together. Each of those numbers is a factor that results in a product. So our greatest common factor, y'all remember this from elementary school, is the greatest number or the greatest factor that they both have in common. So if I were to think about 24, factors of 24, that would be 1 and 24. Then you have 2 and 12. We have 3 and 8. And then 4 and 6. Do you remember doing these in elementary school where you did your little rainbow hoops and connected them? All right, let's do the same thing for 30. So if I think about 30, I have 1 and 30. I have 2 and 15. I have 3 and 10. And then 5 and 6. So So now I need to think about what is my GCF for both of these numbers. What number do they both have in common? And they both have a 6 in common. So their GCF is 6. Now, here's your trick. On your Desmos will tell us the GCF. If we type in GCF parenthesis 24, 30, because those are the two numbers I want, Desmos is going to spit out that 6 is the answer. Now, it only works for numbers. It doesn't work for these variables. The variables we have to use our brains for, but at least this will help us with our numbers. Okay? All right, so let's use this factoring with a GCF to help us out. Okay? So when we're factoring the polynomial, remember we're trying to figure out to get it in its completely factored form, so that if I were to work it backwards, I would have the starting polynomial. Okay? So we are going to actually work it backwards. We're going to divide out the greatest number that the terms have in common. So it's like the distributive property, but it's backwards. So if I were to give you this expression, 8x plus 4, and I were to say, okay, what can you factor out? Honestly, what is your GCF for 4 and 8? Well, if I were to use Desmos and type in GCF parenthesis 8, 4, Desmos is going to spit out that it's a 4. So we're going to use 4. So if I were to think about, if I were to divide this by 4, 8x divided by 4, well, 8 divided by 4 is 2, and the x has nothing to divide by to cancel out. So it just kind of tags along. Then I say, okay, well, 4 divided by 4 is 1. Now, if I were to redistribute these, 4 times 2x is 8x, 4 times 1 is 4. Check, I know my answer's right because I can redistribute it back out to get my original answer. So let's do number 2. Oh, this one's easy. 25y and 25. What do they both have in common? What is that GCF? That would be 25. So if I were to say, okay, 25y divided by 25y is just y. 25 divided by 25 is 1. And again, if I were to redistribute this, 25 times y is 25y. 25 times 1 is 25. You can always check that if you were to work it backwards, that you're going back to your starting answer. All right, let's keep rolling. Let's do some more of this. This is fun. All right, look at this one. We have the factors 16 and 10. So I need to think about what GCF they have. Well, the biggest GCF they have is 2. But look at your x's. You have an x and you have an x squared. They both have ax, which means I can take away ax. Just 1, not 2, just 1. So if I were to take 16x and divide it by 2x, 16 divided by 2 would give me 8, and your x's would cancel out, correct? Now let's do the same thing to 10x squared divided by 2x. 10 divided by 2 is 5. 8 squared divided by 8 to the first. I'm dividing, so I have to subtract my exponents. 2 minus 1 is just 1, so x. Again, I can recheck these really quick. 2 times 8 is 16 with an x. 2x times 5x is 10, and I add my exponents to get x squared. So let's keep rolling. All right, number 4, I gave you a little bit bigger of exponents, but we're going to do the same thing. We're going to sit here and we're going to think about what the GCF is. So we have coefficients of 2, 6, and 18. Well, the only factors of 2 are 2. And if I were to put these 3 numbers in Desmos, they're going to tell me that my GCF is 2. But now I need to think about my variables. This one is x to the 5th. This one's x to the 4th. This one's x to the 3rd. You're always going to be able to pull out the smallest amount of variables. The smallest amount of variables is my x to the 3rd, which means I can take out an x to the 3rd from each one. So if I were to divide each one of these by 2x to the 3rd, 2 divided by 2 is 1. X to the 5th divided by x to the 3rd, I'm going to subtract these. 5 take away 3 is 2. So I'm left with an x squared. 6 divided by 2 is 3. X to the 4th divided by x to the 3rd. I'm going to subtract those. So 4 take away 3 is just 1x. 18 divided by 2 is 9. X to the 3rd divided by x to the 3rd are the same, so they go away. So here's my finished answer. 2x to the 3rd times x squared minus 3x plus 9. All right, let's keep going. Now, number 5. I threw in multiple variables. But let's do it one step at a time. Look at your coefficients first. You've got 7 and 14. They both have a GCF of 7. Look at your x's. You have an x and an x squared. What's the smallest one? Is just ax. So I'm going to take out ax. Look at your y's. This one has 1, this one has 1. So the smallest thing I can take out is 1y. So if I were to divide each one of these by 7xy, let's do the math. 7 divided by 7 is just 1. X divided by x is just 1. Y divided by 1 is 1. Does that mean there's nothing left? No, they're 1. I have to put the 1. Let's do the next one. 14 divided by 7 is 2. X squared divided by x to the 1st. So I'm going to subtract. 2 minus 1 is 1x. But y divided by y cancels out. So I'm left with just a 2x for that term. All right, let's do the next one. 9a to the 3rd b squared plus 12a squared b to the 4th. My greatest common factor for 9 and 12 is 3. Now let's look at your variables. You've got a to the 3rd and a squared. The smallest one is your a squared, so you're going to be able to factor that out. Look at your b's. You've got b squared and b to the 4th. Your smallest one is b squared. You're going to be able to factor that out. So now let's divide each one by 3 a squared b squared. Divide by 3 a squared b squared. 9 divided by 3 is 3. A cubed divided by a squared. I'm going to subtract those exponents is just a. B squared divided by b squared reduces to 1. Let's do your next one. 12 divided by 3 is 4. A squared divided by a squared is going to cancel out. B to the 4th divided by b squared, I'm going to subtract those, is going to be b squared. Now notice, once you get it in your simplified form, there's nothing else you can factor out. You are literally pulling out everything. You're putting it in the most simplest form for each one. All right, for our next one. This just wants us to identify the GCF for each term and then use it to factor each polynomial. So let's look at the first one. 5x plus 10. What is the GCF for 5 and 10? Well, that would be a 5. So I can divide each one of these by 5. 5x divided by 5 is x. 10 divided by 5 is 2. Let's go to your next one. 9a minus 6. The GCF for both of these is 3. So I'm going to factor out a 3 for both of these. So 9 divided by 3 is 3a minus 6 divided by 3 is 2. So, let me rewrite that. Sorry. So it's going to be 3 times 3a minus 2. Now I'm going to look at number 3. What's my GCF for 3 and 18? It is 3. So I'm going to divide each one of these by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. And then I'm going to have that y attached to it. Look at number 4. 18p minus 21. I'm going to have to factor out a 3 for each one of these. 12p divided by 3 is 4p. 21 divided by 3 is 7. All right, let's do the next one. 5g plus 3g squared. Only thing I can factor out of these, my coefficient is the GCF is 1. Only thing I can factor out is a g from each one of those. So if I divide each one of these by a g, 5g divided by g is just 5. 3g squared divided by g is 3g. And that is my answer. All right, look at this next one. 10x squared minus 20x plus 10. Again, the biggest thing I can factor out is a 10. So that's going to be an x squared minus a 2x plus a 1. Again, you're in your simplified form. All right, let's keep going. These are going to gradually get a little bit harder each time. So 45a cubed minus 9a squared. So my GCF is 5. The biggest variable I can pull out is an a squared. So I'm going to divide each one of these by 5a squared. Oh, not 5. Sorry, guys. 3a squared. My bad. Let's rewrite that. 3a squared. So 45 divided by 3 is going to be 15. A cubed divided by a squared is going to be a. Minus 9 divided by 3 is 3. A squared divided by a squared, just cancel it out. So I'm done. All right, look at number 8. Oh, wait a minute. Go back to number 7. If I look, this is in my factored form. There's a bigger number than 3. The biggest number is 9a squared. I didn't use my Desmos. You got to use it. So I'm going to factor out a 9a squared. So 45 divided by 9 is 5a. 9a squared divided by 9a squared is just 1. Now, you're probably thinking, how did you know you weren't done? Because if I can rewrite what I had 15a minus 3. And I know both of those numbers are divisible by 3, which meant I wasn't done. That's how I knew I hadn't pulled out my GCF. So you always look to see what's inside is simplest form. All right, now let's look at number 8. The biggest thing I can factor out of both of these is a 4x cubed. So 4x cubed is what I'm pulling out. Let's see what I'm left with. 4 divided by 4 is 1. X to the 5th divided by x to the 3rd would be an x squared. 4 divided by 4 is nothing, or 1. X cubed divided by x cubed is 1, so that would just be a minus 1. And you're done. All right, let's keep going. All right, look at these. Here's what I want you to do. I want you to pause the video really quick, and I want you to work these problems out yourself. When you're ready to check these 4, I want you to hit play again. So for right now, hit pause, work them out, and then start it again. All right, how'd you do with those 4? All right, now we're going to move on to what we call factoring by grouping, okay? So what we're going to do is we're going to group numbers together. So if you notice, this one has 4 terms, okay? Now you're probably like, oh, but you could combine your terms and have 3. Yes, but not always. We're starting off with an easy one. So what we're going to do is we're going to group the first 2 terms and the last 2 terms together. And we're going to say to ourselves, what can I factor out of just these 2 terms? So if I have x squared plus 7x, the only thing I can factor out, so this GCF is x. The GCF for 2x plus 14 is going to be a 2. So now let's go through and let's factor those out. So if I were to factor out an x on this first one, I would have an x plus 7 left over. Plus, I'm taking out a positive 2, and I would end up with an x plus 7. Well, you notice how these two are the same? It's because they're supposed to be. You want these to be the same. So these should be the same. Because, guess what? Of these two terms now, I can factor out that x plus 7, which means I'm left with an x and a positive 2. Kind of cool, isn't it? Now, you can always go back through and multiply to check it. So you can do your box method, and you can check that you're going back to the same original one. All right, let's try that on some more. So again, I'm trying to group these into two groups and look at each one. What can I factor out of 3x squared minus 15x? Well, that's a 3 and an x. So that would end up with an x minus 5. Plus, what am I able to pull out of this? For a 2 and a 10 is just a positive 2. So that would leave me with an x minus 5. Again, ding ding, same factor. I'm going to factor it out, and then I'm left with what's outside, 3x plus 2. Again, you can go back through and recheck this, that you're getting the same answer. All right, let's do number 2. Again, I'm looking at these two groups. So if I were to look at these two, what can I factor out? Well, I can factor out a 4 and an x. So this would be a 2x plus 3. On this one, all I can factor out is a y. So that would leave me with 2x plus 3. Again, they're the same, so I can factor that out. 2x plus 3, and then I'm left with my other factor of 4x plus 1. All right, let's step it up. Look at this next one. Again, we're going to group by 2's. So in this first one, the only thing they have in common is an x. So I can say that is going to be x plus 2. Look at this next one. Negative 7 and a negative 14. Now, if both terms are negative, then the GCF is also negative. So I'm going to be able to factor out for both of these a negative 7. Notice on these I factored out positive 2, positive y. I put that symbol. Just like here, I'm going to put that negative 7. Because when I factor out a negative 7 at a negative 7x, I'm just left with a positive x. Negative 7 factored out of a negative 14 is a positive 2. Again, look, they have a factor in common, x plus 2, that I'm going to factor out, and I'm left with my x minus 7 factor. Kind of cool, isn't it? All right, time for a challenge. Let's look at this one. If I were to look at this first one, if I look at my coefficients, greatest common factor for those is 5. Look at your variables, x to the third and x squared. This one's the smallest, which means I can factor it out of both of them. So 5x squared factored out of 10x cubed is going to be 2x. 5x squared factored out of 25x squared is going to be 5. Look at your next one, 4x and 10. Greatest common factor is going to be a 2. 4x divided by 2 is going to be 2x. 10 divided by 2 is going to be 5. Again, have a common factor. You can factor it out. And then we're left with 5x squared plus 2 as our secondary factor. And again, you can factor these, and you're going to end up with that answer. And that is factoring by GCF.